In this video we're going to evaluate the derivative of e to the x, and to do that we are going to use a limit definition of the derivative. So if we let y equal e to the x, then we know that dy dx is going to equal the limit as h approaches 0 of f of x plus h. In this case that's going to be e to the x plus h minus f of x, that's e to the x, all over h. And if we try direct substitution right now, we can see that plugging 0 in for h here will get e to the x minus e to the x, which is 0, all over h, which is 0. Direct substitution is not going to work, so we are going to have to rewrite this. So we'll use some properties of exponents here. We know that e to the x plus h is going to be the same thing as e to the x times e to the h. So what I'm going to do here is I'm just going to copy that whole thing, and instead of e to the x plus h, we will replace that with e to the x times e to the h. And that is true by a property of exponents that we should know. Now we can take this expression on top and factor out an e to the x. So this is going to equal the limit as h approaches 0 of e to the x times the quantity e to the h minus 1 all over h. And if we look at this limit here that I have provided, this is a limit that we could check the validity of this limit by using a table or by using a graph, but it turns out that the limit is as some number approaches 0 of e to that number minus 1 all over that number is going to equal 1. This is an indeterminate limit, 0 over 0. There's no way to really evaluate this algebraically. We would just have to evaluate it by looking at a graph or looking at a table. But we can use this idea here that e to the x minus 1 over x approaches 1 as x approaches 0 by looking at this part of our limit here. This e to the h minus 1 over h, that part right there is going to go to 1. So then this whole thing is going to equal e to the x times 1, or just e to the x. So that means that the derivative of e to the x is e to the x. It is its own derivative. If we wanted to apply the chain rule definition, or the chain rule equation that we would get, the derivative of e to the u, where e is some function of x, is going to be e to the u times the derivative of u with respect to x.